the way, don't get obsessed with this, but this is the cool recording up here. If that ever goes off, let me know. That means I've run out of space on my disk drive. All right, first thing I need you guys to label today, this is Algebra Review, Day 1. And we're going to call this Equations of Lines and Solving Equations. So that's what we're covering today, equations of lines and solving equations. Now, we're not covering every way of solving equations. We're just going to get some of the basics that we've had before. But first of all, let's talk about equations of lines. You are going to be expected to know these at every level of math. You apply it in science classes, you apply it in math classes, so we cannot get away from what we know. So first of all, what was one form of a line? What was, let's start with my least favorite form. Standard. Yeah, you know it right away. Everyone's like, standard. Yeah, that's my least favorite form of a line. Standard form. Can anyone remember what it is? Yep, ax plus by is equal to c. Excellent. Now, talk to me. What else were some of the stipulations with this? Right. A is not negative. Is not negative is cannot be. I like better saying cannot be. Cannot be negative. Now, you will see it written as a negative, but when you're trying to write as a whole class, you want to make sure we're all in the same form. All right, what's another thing we know?
Do you have to be like a real number?
Yeah, a little bit more. What's so special about whole numbers? Mean you can never have a negative. So what's another word we can use? A, B, and C must be what? Integers. Very good. Integers, whole numbers and their opposites. So basically, no fractions and no what? No decimals. No fractions and no decimals. So if you have that, that's not standard form. Let me give you a quick example of this, something really simple. How about like 3x minus 2y is equal to negative 6? All right. Now, looking at that, very simple, very straightforward. Quick question. What's the slope of that line and what's the fast way of finding the slope of that line? Amanda? You could do y by itself, but that's not the fastest method. You would get it though. All right.
Isn't it there in equations like m is equal to b over?
Close. You're right. M equals something. Close.
There's something. There's an equation. It's like something b or negative b over.
It's not negative b. It's negative what?
Negative a.
A over b, which is what you get when you're solving for y. So it does the work for you. So this is the opposite of a over b. That's one way of quickly being able to find the slope. Why is this important? To write other equations of lines. What if I want a line that's parallel to that? What would be the slope of the line parallel? Or what if I want the line that's perpendicular to that? That equation would give it to us, right? So what's the slope of this line? No, negative 3 over negative 2, which is what? 3 over 2. You need to know that because what if I want one that's parallel? What's the slope of the line parallel to that? 3 over 2. What's the slope of the line perpendicular to it? Negative 2 over 3. Exactly. Now, how do you graph the quickest way? How do I graph this the quickest? Exactly. We use the intercepts. Good. We call it the cover-up method, or I like isolate the word also. Cover-up method, which really means what? Find your x and y intercepts. So remember, if you have an x-intercept, that's an ordered pair. Your x-intercept would be a0, and your y-intercept would be 0b. So let's look at this one real quick for this line. If I get 3x minus 2y is equal to 6, if I'm looking for the x-intercept, which one do I cover up? You cover up the y. So then you get 3x is equal to 6, x would equal to 2, your x-intercept is 2, 0. Now doing the same type of idea, in order to solve for the y-intercept, instead I cover up what this time? We cover up the x. Do I cover up the negative, or I make sure I leave the negative? Leave the negative. So I get negative 2y is equal to 6. So y would equal a negative 3. So my ordered pair is 0, negative 3. Now why is this such a nice method? How many points do we need to draw a line? We only need 2. So let's just do a quick graph without making it too complicated. So we just have to graph the 2 points. So here's your x. We're at 2, 0, and we're at our y as 0, negative 3. Boom, you're done with that line. Don't even have to worry about slope. No worries. Lucas is like, I'll finish this song. All right, so just remember, quick, easy method. So if all they want you to do is graph, and they don't specifically say what method to use the cover-up method. Now, which method is my favorite? Hands down. Point slope. And the cool thing is point slope works even on your AP Calc exam. All right, who can tell me point slope? Which one is that? Y what?
Y minus y1 is equal to m times x-intercepts.
Very good. We should have y minus y1 equals m times the quantity x minus x1. And remember, m is your slope of the line. M equals the slope. And x1, y1 is any point on the line. So the cool thing is it will work no matter what, basically, unless it's a vertical line. And then none of these methods really work. So we have a vertical line. We always use, basically, if in doubt, you use point slope to set it up. Let's do a quick example of this one that we'd have written. Something like this. Y plus 3 is equal to a negative 1/3 times the quantity x minus 2. What's your slope? It's a negative 1/3. What's the point? Careful. 2, negative 3. Be careful that you don't. It's very easy to do that, isn't it? With this, because the y comes first in the equation, so it's easy to get changed around. And then you should be able to graph this. How do I graph? Graph by, first, plotting the point, then using slope to get the second point. Now remember, this is where algebra teachers and myself are very different. Algebra teachers make you keep going on forever, like 3 to 5 points. This is Mrs. Gregerson. I think you should do it fast, and only how many points do you need is just 2 lines, so why do I waste my time otherwise, you know? So let's make sure we get this on here. I think next year you have to plot 3, so just remember that. So my point's over here at 2, negative 3. Then I go from that point, not from the origin, I go back to that point, and then I do the slope. Where do I put that negative, top or bottom? Top. Always let your negative tell you to go up or down. Do not put it in the denominator that messes you up, okay? So in this case, do I go up or down? We go down 1, over to the right, how many? 1, 2, 3. Excellent. There would be your other point. Quick to graph. All right. This is the one I live with because it's not my favorite method. Which one is it? Yeah, slope, intercept form. Slope, intercept, and actually you just made me very, very happy, Lindsay, because you called it slope y-intercept. Thank you. Nope. All right, every math book out there just calls it slope intercept, but really it only works for the y-intercept. So why don't we get more specific here? Okay, slope y-intercept. So we get y equals mx plus b. M again equals your slope. And b is the y coordinate of your y intercept. But remember, your intercept is a point, not a number. I don't care how many times people say otherwise. So this example here, you should get y is equal to 3x minus 4. What is your slope on this one? Yep, 3 over 1. When we pull out slope, it's always good to put it over 1 so remember we're graphing. What is my y-intercept? Oh, good job. If you would have said -4, I would have been like, what? Good, good save. It's a point, 0, -4. Now, if I have a point in the slope, is it going to be really easy to be graphing it? Yeah. Just same as above. Graphing these really don't change. The cool thing about slope intercept and point slope form, you start with a point, you use a slope to get to the second point. It doesn't really change that much. Now this isn't earth-shattering, you guys remember it from first semester, it's just been a while. So we want to make sure we can do it well. But also remember about vertical and horizontal lines. Vertical lines and horizontal lines. A vertical line, because I remember the equation for a vertical line. Think real quickly, which axis do you hit if you have a vertical line? X. Remember, vertical lines, there is an undefined slope. So since your slope is undefined, I can't use any of my methods. So if you have a point, we know it has to hit x equals some value. And where does that value come from? If you know a point on the line, it always will be the x value. The x coordinate of it. When you have a horizontal line, what's your slope going to be? Our slope is 0, and so this time it's going to be y is equal to b, whatever your y-intercept would be, or whatever your y-coordinate of any point on that line is going to be, because it never changes. It's just y equals that. So keep it very simple. Also, don't forget, like what you guys said earlier, slopes that are parallel are equal. Your slopes that are perpendicular are opposite reciprocals. All right. That's the review of lines. Trust me, I'll answer a lot of questions the next few days because I want to make sure you're doing really good on the homework.